Hey, hello again. I'm here at Rose State College in another lab. I have with me here today 3 constant velocity tubes. In them there are 3 different oils of 3 different viscosities. Not something we're going to go over today, but what we are going over today is what you see on the board there behind me, constant velocity. Okay, what we're going to do is, what happens when you use a constant velocity tube, you turn it upside down very carefully, and you note that 2 bubbles, one inside of one tube, one side of the other, they move at a different rate. Okay, different rate, different distance per unit time. Okay, and that is exactly what we're going to be measuring today, distance per unit time, with this blue tube. What I'm going to do, you see behind me there's a ramp set up, and I'm going to lay the tube on top of it. We're going to mark the leading edge of the bubble every 10 seconds, okay? So, let's begin. And we'll begin in 3, 2, 1, now.
Start. Time. 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 Time.
Okay, so a mark was added at the beginning of the tube, but other than that, all marks are still the same. So what we have here is a meter stick. We're going to measure the distance between each one of these, and again, each distance you see here is a 10-second progression, 10 seconds, where time is equal to 10 seconds each. Let's see how much time overall was passed. 10, 20, 30, 40 seconds. 40 seconds overall. Okay? So now, let's measure the distance between each mark to see the accuracy of our constant velocity tube. So from here to here, from the beginning to the first mark, that is roughly, as you can see, I've tried to put this in the middle of the mark here. To here, it's about 24 and a half centimeters, okay? We're going to call this 24.5 centimeters, okay? Let's move along. Okay. Slightly less than 24 and a half. It is about 24.3. 24.3-ish centimeters. Okay, let's move along. Okay, what do we have here? Roughly, looks like again, about 24 and a half. And again, errors could have been made in my marking of these, but so a little bit of human error. Always have to acknowledge the errors that humans make along the experimental process. But what we have here is roughly, looks like again about 24.3. Okay, thereabouts. So, do you remember in our previous video how we calculated an average speed? Very good. That's right. You take the overall total distance traveled, okay? Take the total distance traveled and you divide it by the overall time of travel. Okay, and let's actually do that, okay? What we have is 24.5, we have 24.5 times 2, okay? 0, carry the 1, 2 times 4 is 8, 9, okay? 2 times 2 is 4, all right? 49 here. Then we say we got 24.3s. 24.3 times 2, we get 6. 2 times 4 is 8. 2 times 2 is 4. So then we add these two together. 49.0 plus 48.6. There's times right there, just letting you know what we're doing. 6.9 plus 8, 17. 8, 9, 97.6. Okay, 97.6 centimeters in travel overall. 97.6 centimeters. And so what is that? What are we trying to get? We're trying to get meters per second. So let's turn it into meters. Everybody remember how to do that? Move the decimal place over 2 spots. 0.976 meters. Okay? And how many seconds do we have that we're working with? We're working with 40 seconds overall. Okay? And so we divide. I wouldn't expect you to know how to do that off the top of your head, but 0.976 divided by 40 is equal to 0.0244 meters per second. Okay? That is our average speed by taking, again, the total distance traveled divided by the overall time of travel. Always box your answers. Thank you again, and this has been an example of constant velocity. Look forward to the next video.